So now this delete operation in binary search tree, you know the three types of delete operation in binary search tree. Can anyone tell me that? How you can delete the node? There will be three types of deleting a node.
Sir, if no child, we can
Zero child, yes.
one child, two child.
One child, two child. So zero child, you are just deleting the node as per the requirement, and if it is one child, then you have to follow some certain rules and regulation for the one child. So most probably this two will be most probably the same, and this two child node will be whether you want to take a left child or you want to take a right child. How you will take the left child and right child? The greatest in the small greatest in the left hand side and the smallest in the right hand side that you want to take, and you want to delete those things. So that is the basic operations of the deletion process in the binary search tree. I will go with an example here. So you just forgot this lines of code. You just see this image. You see, just see this image. Can you tell me which one is the zero node? Which node will be the zero node? Zero child. Which
98.
node? So 98 is my zero child node. So first I want to delete this. So first what we want to do when we are going to delete an operation in the binary search tree, first condition what you will check.
Node is there or not?
Yes.
Whether it is null or not.
Yes, first you will check whether tree is having any data or not. First you want to check the entire tree whether tree is null or not. If it is null, then the representation will be like this. The tree is null, or you can't able to delete those things because of tree is null, you can give an output. If the tree is having a root node alone, if the tree is having any one of the element in the tree, then you will want to do the checking process. If suppose my data is 98, then what I want to do, I want to delete this 98, and what I have checked that whether the tree is null or not. And after that, what I want to do, I will check first. I will check whether this root node is greater than or less than to the this key is greater than or less than to the root node. We want to find out that, right?
Sir,
Yes, yes. If it is less than, you want to search in the left hand side. If it is greater than, you want to search in the right hand side. Am I right? If it is less than, I want to search in the left hand side. If it is greater than, I want to search in the right hand side. So if I am searching this, so it will be first condition. I will check whether tree is empty or not. No, the tree is not empty. And again, I will check whether 98 is greater than 10. Yes, 98 is greater than 10. So I want to search in the right hand side. For this, I want to write a code in the first step to check, to find out whether tree is greater or equal to whether tree is present or not. And after that, you want to find out whether the given element is greater than or less than. For this, we want to write the first lines of code. So as of now, what we have done the insertion, search, traversal method, and finding out the minimum and maximum. So after that, we want to do the delete operation. So first, what we want to do, def is my function name, and here I am giving the function. Def is my function definition, and here I am giving the function name and passing the self argument. Whether we want to insert any arguments over here. Whether I want to pass any argument for deleting a function.
Yes, sir.
Yes. Why? Because we will want to, here you can see here when you are searching a function, you have passed one argument. So it means it will search the particular value 30 and it will be displaying the result. So here we want to pass one particular argument to delete those particular values. So I am taking that as data here. So that means I am passing on data to the delete function. So this is my first step. So first what I told is I want to check if self dot key is none. Then what I want to do, print P is empty. So this is my first message, and after that I will give you the return value. What it means, the return value, it will not return anything. It will return only just key is empty. So that is my first step. What is my second step?
where data is less than key or greater than key, sir.
Yes, where you want to find out whether the data is less than the key or greater than the key. 1 minute. So if and three condition we want to check. Just see where this. Three condition you want to check here. One is whether the data is less than key or greater than key or equal to key, equal to self, right? Three condition you want to check. If I am,
Sir.
if suppose you can check, you just find out that I want to delete the 10. If I am checking only greater than and less than, it don't applicable. 10 is equal to 10. So we want to get three condition in the statement. So you want to check three condition. For checking the three condition, you know that in the control flow, if, else if, and else statement, right? For checking three condition, you have studied in PSPP. For checking the three condition, if, else if, or else. So we want to take three conditions over here. So first I am taking the if condition, that data is less than self dot key. If, again I am going to that, if self dot L child is present. If the self dot, just first I write the code and I will explain you. Self dot L child is equal to self dot L child dot delete of that. Is also button is greater than self dot key. Self dot child is present, then self dot child will be self dot child dot delete with the so this is the code. What I have done, can anyone tell me for the data is less than of self dot key? Just find out these three lines of code and tell me what I have done. You can see here the code will be there. So here you can see that I'm checking that self dot self if data is less than self dot key. What is my data? So if suppose I am taking my data as 98. So this is my data. So data is, that means, so here the data will be 98 now. So now it will check 98 is less than self dot key. What is mean by self dot key? So this is my self. This is my self root node, that is self node, and 98 is less than 10. The condition will be 98 is less than 10.
False.
The condition false. So it won't work. So this if statement will not work. It will directly go to the elif statement. So 98 is greater than self. The condition.
True.
The self is 10. So this condition will be true. So now what I have done is I want to check whether self having or child. So what is the mean? If the root node, if the deleting node is greater than the self node, I want to check whether self, whether the root node having any right child or not. So that's why I'm again using the if statement. If self dot or child, whether root node is having the right hand side node. Yes.
Sure.
Yes, so root node is having the right hand side node, so it means that it will it will execute the if part. Here you can see here self dot r child is equal to self dot r child dot delete. So this means self dot, this is r child and this is left child. So it means self dot r child is equal to self dot r child dot delete. So now this will move as to the self. So now this will move to the self. I understand my point. So we are transferring, we are going with, so whatever we have done in the insertion process, search process, what will happen? The root node will be moved to either in the right hand side or in the left hand side. So that is the condition I have written. Self dot r child is equal to self dot r child dot delete. So this will be now act as a self node. In the previous step, this will be acting as a self node, and now this will be act as a self node. So again, we are calling this regressive function. By this self node is known as 98. So now the data will be same as 98, but the self dot key will be changed as 98. Now you can check the condition. 98 is less than 98. The condition will be 98 is less than 98. The condition
False.
false. So now this if part will not work, and again it will go to this else if part. 98 is greater than 98. The condition will be
False.
false. So this else if part also will not work. Then again we want to go to the else part, that we have find out the node. Once we have find out the node that will represent as yourself, and that stage that will represent as yourself, and how to delete those self, then we will see that. And how to delete those cells. So here you can see I have find out the node that is 98, that is equal to deleting process. So what I want to do, you can see here, if self dot l child is none. So we want to check whether this is my self now. So finally this is my self now, and you want to check whether any child node is available for that particular 98. So if self dot l child is none, yes, the self dot l child is none. So temp is equal to self dot r child. So this is my left hand side and this is my right hand side. It means the right will store the value called temp. It means that the null value will become temp, and self is equal to none. So this self dot key will become none now. So this will become none and return the temp. It means it want to return the previous regressive function that will return the temp here. So it means the null value will be written here. So this address will be removed and this null value will be inserted here. And in this part, this key has been deleted and it won't display the result. So this is the thing. First, you want to check the less than or equal to, and after that, if it is less than, you want to make that node as your self node. Till that, this regressive function will be working. Till this node will have to make the self node, the regressive function will be working out there. Once the regressive function has been called and when the node has been finalized, this two method will be getting false and it will directly go to the else statement, and it will check whether any left hand side or right hand side node available or not. If L child is none for this 98, this is myself, this is myself, this left hand child is null, yes, this left hand side is null, and temp is equal to self dot r child. So this is my temp, so this is my self, and this r child will become, this null will become now as temp. So temp is equal to null, like that it will be happens, and self, it will return self is equal to null. So this self key will be null. It will delete this 98 and this will become null, and it will return the temp to the previous method what you have called. It will return the temp. That means self, previously the self will be here. So self dot l, so sorry, we have searched here. Self dot r child will be null. So here the self dot r child value will become null. So it will go there and it will produce the result as null. So that is the thing. So it will delete. So if it want to check whether the root, whether the particular node available any left node or right node. If it is left node available, it won't interchange the right node. It will be right node available, it interchange the left node. So that we will discuss when you are deleting the one child node over here. So clear, or I want to explain it one more time, or else I can go with the one child node deletion process. If you are having any doubt, you can ask me. Yes.
Okay, sir.
Yes. Now you can tell me, can you tell me, suggest me the one child node available here?
3.
3. So yes. So if, now what we have done, we have deleted the 0 child node, and now we will go with the one child node process. So one child node also will be as of like that same for the 0 child process. So here first I will go with this 3. So my data will be 3 now, and here I am checking that whether tree is none. No, the tree is not none because we are having a self dot key value that is 10. So this is my self now. So self dot key value is 10. And now I am going to check this condition. If data is less than self dot key, that is 3 is less than self dot key, that is 10, the condition will be
True.
true. The
So,
condition will be true. If the condition is true, it want to execute this process. That is, if self dot L child, self having any L child here, left hand side child.
yes, sir.
Yes. So this is my self dot L child. So I am having self dot L child value. If self dot L child is present, then what I want to do, self dot L child is equal to self dot L child dot delete. So it means this, now this will take as the self node. Because why? Because this is an regression technique. So this will act now as a self child. So again it will go here, the data will be 3, and if data is less than self dot key, that means 3 is less than 6, the condition will be
True.
true. So it means that this is true. So again this self if function will be working out here. So it will find, again it will find if self dot L child is present for this particular 6, the condition
True, sir.
true. So yes. So what will happen if self dot L child is present, then self dot L child is equal to self dot L child dot delete. So now this will become your self. Again the regressive technique. So now this will become your self. So again what will happen? Again it will go and check that 3 is greater than less than 3, the condition. 3 is
False.
false. So if this if statement is false, then it will go to the else if statement. Here it will check 3 is greater than 3, the condition.
False.
False. So if statement also false, else if also false, it means we are going to the else statement. It means anyhow we have find out the node. So that is the process. And if the first thing we have, what we have done, we have not inserting any duplicate value inside the binary search tree. That is my first point that we have discussed. If the data is less than self dot key and data is greater than self dot key, this both condition has been false, then the condition will be you have find out the node that you want to delete. So now the deletion process will be happen. If self dot L child is none, if self dot L child, so this is my self as of now. If self dot L child is none, the condition, whether this is true or false, self dot L child is none.
False.
False, because we having a left hand side. For this is my self and self is having a left hand side, so this condition will get false. If self dot R child is none, the condition
True.
True.
true. So it means we have find out that this is the self dot R child is none. So we have find out that this is the one child node. So temp is equal to self dot L child. So this will become temp. So temp is equal to 111. That is the value. So this is my address. So temp is equal to 111. And self is equal to none. It means self is equal to none. So self dot key will become none now. And what will happen? Return temp. So it want to return this self value, want to return the value for the previous self value. So it means returning the temp here, and this 3003 will become 111. So it means how the structure will be, this will directly go to this point. So this will be deleted. So finally, what is the thing? This is my self. And if self dot L child is none, no, the condition is false. If self dot R child is none, yes, the self dot R child is none. So if previously this is myself and previously this is myself. So what I am doing, self is equal to self dot L child. So temp is equal to self dot L child. So this is my temp. Temp is equal to 111. Likewise, it will be stored because of the address. So temp is equal to 111. So self is equal to none. So this self value will become none. It will be deleted. So it will become none. And we want to return the value for this particular. We have taken the condition here. We have taken the condition. First, we have taken the condition here. So we want to return the value to this particular condition for this particular last self. So it means it will return the value as 111. So it will return the value. So now this node has been deleted, and here previously self.lchild value has been changed to 111. It means it will point out directly to the 111. So this node will be deleted. So this process will not happen. Clear? Clear about this? Or I want to explain this again. If you are understanding this, and deleting the two nodes will be easy. Deleting either our nodes, deleting a two child node will be easy.
Once again.
Once again. So first, don't with the code. Don't go with the code. Go with this process. Don't go with the code. So here I want to delete the value called 3. So I want to delete the root node. I want to delete an element as 3. So first I want to find out whether the root node is available in the left hand side or in the right hand side. So I will check this with the self node. So in the first step, this will be my self node. So first step, this will be my self node. So first I want to check whether this is greater than or less than. So here we are finding out, yes, it is greater than less than. So I want first, initially I have mentioned that I want to travel this based upon this node in the left hand side. So that is my first step. So I don't need to worry about this right hand side, because the node will be available, either the node will be available in the left hand side or the node will not present in the tree. This two condition I want to take. I am not bothered about the right hand side. So after that, I want to check whether any left node is available for this cell. Yes, the left node is available. So the regressive technique will be working here. So if it is left node is available, I want to change this self as here. So why? Because I want to identify the node which I want to delete. That node I want to make as my self. So that is the process. So here I will check whether any left hand side node is available or not. Yes, the left hand side node is available. So that I want to make as self. And again I will check with this self. 3 is less than or equal to, greater than or equal to, or 3 is equal to 6. So I want to check this. So if I am checking this, 3 is less than 6. So again I want to travel in the left hand side. So what will happen? This again I want to make this node as my self node. 1 minute. Sir, சொல்லுங்க சார். ஆமாம் சார் சொல்லுங்க. ஏன் சார் என்னாச்சு? சரி சரி. So this I want to make my self node. And again what I want to check. So here I want to check with 3 and 3. So it will be either greater than or equal to, less than or equal to, or 3 is equal to 3. So that I want to check. So here the condition will be 3 is equal to 3. So for this, if I am checking, so what will happen now? First this is myself, and again this is myself, and here this is myself. For 3 is equal to 3. So now I want to check 3 is less than self dot key, false. 3 is greater than self dot key, false. So now self dot key will be 3. So data will be represented as same as 3, and self dot key will be changed one by one. That is 3, 3. So it means if both the condition is false, that means 3 is equal to 3. That we have want to identify that we have find out the element to delete it. So if again what we want to do, we want to find out whether for that particular 3 we having any left child or right child. If it is we having a left child or right child, we want to connect this child to the particular node in the previous self. We want to connect that particular node in the previous self. So if self dot L child is none, so this is my self, last self, and I want to find whether self dot L child is none. No, this condition will get false. And here I want to check self dot R child is none. So self dot r child is none. Yes, the self dot r child is none. Now I want what I want to do. Temp is equal to self dot l child. So I want to change. So it means that l child value is available over here. So I am changing that l child value is temp. And after that, self is equal to none. I am deleting this value. Here the deletion process occur. I am giving the self value as none and return the temp. Whatever the value that was stored in a temp, that will be returned. That has returned, and this also will be none. So you can see here, finally this all node will become none. Finally, this all node, how it will be represented? If you are returning the value, that node left child will be none. And here we are deleting the value, that also will be none. And the right child value is already none. So it means all the node will be none. So the node will be deleted automatically. If you are returning this 111 value over here, it will replace this 3003 and it will produce the value as 111. And it will be returning the value and it will be connecting with the 111. So it means this node has been deleted. And after the 6, the left hand side node will be 1. That is the concept. Clear around one more time.
Say with code, sir, no? Lines of code.
Sir, when return temp is over, then what step it will take, sir?
Return temp, if in this case the final step is return temp, right? And return temp, and where the function has been called, final function has been called from here, right? It means the regressive function has been called from here. Am I right?
Yes, sir.
So this return will be going to the value, return temp value over here for the self 3. This is my self, and for that self, the regression function has been called. For this previous self value is the like, so I will go with this code. So now you can take this, I have not entered the code. So if self dot l child is none, then what I want to do, temp is equal to self dot r child. Self is equal to none and return temp. So now you can take this. I'm taking the node. So I'm taking the node as 3 now. So the data will be 3. So so now the data will be 3. So now it will check self dot key is none. No, the self dot key is not none. So it will go here and it will find out 3 is less than self dot key. So here the self dot key will be 10, right? First self dot key, it will be 10. So now what will happen? 3 is less than 10, the condition?
True.
True. So if the condition is true, this part will be executed, right? Yes. So if self dot l child is present, so if self dot l child is present for that particular 10 having any left hand side node, yes. Self having any left hand side node, yes. The condition is true now. True. And now this will be happen. So self dot l child will become now as self dot l child dot delete of data. So it means this will return as self. So this will act as self now. Clear about as of now, you are clear now. This will act as self now. So that is the code I have written. Self dot l child is equal to self dot l child dot delete. So it means it will go to the delete operation by using this self dot l child as my self. Clear? So it will be represented as self. So that is the concept. So this will be represented as self. So now again it will go to the transfer. If self dot key, that means now this will be the self. Now this will be the self, and it will find out whether the self dot key is none or not. Yes, the value, this is not true, so it won't execute this. Now what will happen? The data will remain same. 3 is less than, what is the self dot key now? So now this is the self, and the self dot key will be 6. So 3 is less than 6. The condition will be true, right?
Yes, sir.
Yes. So again, it will go to the if statement and it will check self dot L child is present or not. For this particular 6, whether the self dot L child is present.
Yes, sir.
Yes. So it will, the condition is true. Now what will happen? Again, the self dot L child. For this is my self, and self dot L child will act as my self. So now what will happen? Self dot L child is equal to 3. So now this will act as my self. So again it will go here, the data is 3, and if data is less than self dot key. So 3 is less than 3, the condition.
False.
False. Then this if statement will not work, it will directly go to the else if statement. Else if statement, 3 is greater than 3, the condition.
False.
False. So the statement also will not execute. Then we want to identify that we have find out the node to delete. So that is the concept. If data is less than 3 is not satisfied, if data is greater than 3 also not satisfied, then we want to find out we have reached the node that you want to delete. So now we want to go with the delete operation. So here first we want to check out if the if condition is false, then it will go to the else if condition. And the else if, sorry, if condition is false, then it will go to the else if condition. Then the else if condition is false, go to the else condition. Now, if self dot L child is none, so now final self is this. So self dot L child is none. Is this correct?
No, sir.
Self dot L child is none.
No, sir.
No. Then this statement will become false. And here it will go to this statement. So self dot R child is none. True. So now what will happen? Temp is equal to temp dot L child. We having one value in temp dot L child, right? So it means we having one data. We have checked this. So we having one data, that is temp is equal to temp self dot L child. So this triple one will temp will make this as triple one. That value will be taken. And here self is equal to none. Now the self value, that is 3, will be deleted. 3 will be deleted now. And return the temp. This temp will be written where the temp will be written is, it will return the value where this before self has been called. So where the before self has been called, here the before self has been called, it will return the particular value to here. Here the value will be returned. Return value will be placed here. And again it will go, again it will regressive the process, and it will regressive the process, and it will directly go to the root node, and it will be after deleting node, the link will be like this. So it will be deleted and the link will be like this. So that is the concept. You just practice the lines of code with an example, and then you can able to understand. So when you understand the concept, how it was deleting here, then this code will be easy. The only one thing, the return statement will go to the regressive function. So anyhow, the value need a return statement. That return statement will go to the regressive function where the function has been finally terminated. Where this two if statement and this else if statement has been finally terminated, that in final stage, this return temp will be going to there. Clear? Have you understand this concept here, what I have explained now? Any doubts? So you just practice this code in with your paper and pen, then you can able to understand easily. And one more condition is pending here. What is that condition?
Deleting do not child parents.
Yes. Self dot child. So I will write the code first. Node dot child is present. And what I want to do, node is equal to node dot HL. Self dot key is equal to node dot key. Self dot chain is equal to self dot chain dot delete of node dot. So now this is the code for, so first I will explain you how this will be happen. So here I want to delete the value of 10. So 10 which will be consist of two child node, right? Yes. Yes. So I want to delete a value of 10. So I have told you that we can go with either right hand side or you can go with either left hand side. Yes. So I am going with this as right hand side. I am going to compare the value with the right hand side. I am going to delete those things. And now what I want to do, I want to do same operation. I want to, whether data is less than self dot key, the condition. Data is 10,
False.
10 self dot key is also 10. So this condition will be false. And else if condition, data is greater than self dot key. Data is greater than self dot key. 10 is greater than 10.
No, sir. Equal.
So yes, this also will be getting false. And here self dot L child is none. So this is my self. As of now, this is my self. Whether self dot L child is none.
False.
False. Self dot R child is none.
True.
Self dot R child. This is my self.
False.
Self dot R child is this. This is not null. This is also not null. So this all the statement will be terminated. So if all the statement is being terminated for deleting the two child node, then what I want to do, I want to search the highest lowest value in the right hand side or highest value in the left hand side. For this searching purpose, I am going to do an operation. This node is equal to self dot R child. Now this, so now node is equal to self dot R child. So now this will become my node. So I am giving this, this is become my node. And what I am doing, I will search whether any self dot R node dot L child is available for this particular node. Whether any self dot R node is available for this particular node. Self dot L child, because we are searching for a minimum number of value in the right hand side. Am I right? Yes. In the right hand side, if I am taking right hand side, I want to take the minimum value in the right hand side, right?
Yes, sir.
So I am searching this minimum number in the left hand side. It means the minimum number will be present in the left hand side. In the right hand side, in this left hand side, no, all the node in the left hand side, the minimum number will be present. So if you are having a node, one more node called 75 and one more node called 100. So the tree will be like this, right? So it means that that particular node left hand side will be all the minimum value will be present. Am I right? 74 and 99. So only in the left hand side, all the minimum value will be present. So I am now going to search with the left hand side node. So here you just see this 3-line code, you can able to understand. Node is equal to self dot R child. So I am assigning node. So this is my self. This is my self. And this is my node. So I am assigning this self dot R child as my node. And I am checking whether node having any left child or not. So whether this 98 node having any left child.
No, sir.
No. So it means this condition will be false and this statement will not be executed. And this, it will come to this statement. Self dot key is equal to node dot key. Only one process. If you want to get the lowest number here and finding out the lowest number, we want to replace that number with the key. Now what will happen? This 98 will be replaced by 10. It means self dot key is equal to node dot key. So this 98 has been replaced. Here. Okay, if suppose I am having, just imagine, if suppose I am having 74 and 100. Just imagine, if suppose I am having that, I want to delete this root node. So what will happen? Node is equal to self dot r child. So this will become my node. And again, while node is having left L child, whether this condition is true or false?
True.
True. So it means that node is having L child. So this statement will be executed. Now the node will be changed. Node is equal to node dot L child. So now this is not my node, and this is my node. This is my lowest number in the right hand side. So this is my node. So what will happen now? Self dot key is equal to node dot key. So it means 74 will be replaced here and 98 will be replaced here. See, sorry, 10 will be replaced here. 10 will be replaced here. Are you getting this? Finally, we will delete this 10. Till now, are you getting this? Simple concept, only 3 lines of code for this deleting purpose. You just imagine 74 and 100 I am having for this 98. So I am having 2 children here. So I am going to delete this 10. So this is myself, and first step, this is my node. And after the node, I want to find out whether if in the right hand side, only left child will be having the smallest value. So that's why I am going with the left node dot left child. So while node dot left child is present, yes, the node dot left child is present. So now the node will be changed to node dot L child. So now this will be my node. So it means the 74 and the next time self dot key is equal to node dot key. So it means this 74 will be changed here and the 10 will be changed here. Sorry, the 74 will be changed to there. The self will not be replaced. So here also it will be 74 and the 74 will be changed here. Are you getting this? So the 10 will not replaced here. The 74 and this 74 also will be changed. It means node is equal to node dot L child. Sorry, self dot key is equal to self dot key. So self dot key will be changed. The self L child value will be remain same. So it means you can see here this binary search tree. In this 74 less than values are present in the left hand side and 74 greater than value are been present in the right hand side. Am I right? Yes. Now what will happen? This self dot r child will become the regressive function with the node dot key value is 74. So now based upon this 74, the data now will be 74. It will go the regressive function. The data will now be 74 and previously in this function the self dot key value will be remains as 10. So it will check the process. And anyhow, the node will be deleted in these 2 cases. For this 74, this is a 0 child node, right? Yes. Am I right?
Yes,
so this is a 0 child node. So this node will be deleted by using this 0 child node property. So likewise, we want to move with the right side process. If you want to go with the left side of the node, what will happen? Self dot r child. You want to change this as self dot L child. While node having self dot r child, you want to check the greatest number. You want to find out the greatest number. Then you want to check with the right hand side in the left node, left tree. You want to find in the right hand side. Here you want to find the left hand side, and here you want to find outside right hand side to find out the greatest number. Here you want to find out the smallest number. So that is the condition. While you are executing the code, you can able to understand.
Sir, before that we written odd child.
Before that.
Sir, last.
This
last. Sir, no sir. Second line last from last.
This
calling odd child. Yes sir. Deleting.
Self dot r child.
74 is left child sir.
Self dot r child. Right hand side, right?
Sir, right hand side 100 is sir.
Self dot. So here the self dot r child. So what is this? What is this? This one, this 74 will not be considered. This is the data we are going to give here. In the final tree, what is this? This is your right hand child, right?
Yes, sir.
And in the right hand child, you want to search for a 74. That process will be happened here. In the right hand side, you want to search for a 74. So you just imagine that this is my final statement that I am giving here. This is my final statement to delete the particular node. So normally, where is my node in the tree?
Right. Right hand.
Right side. Normally the node is in the right side. So I am giving this right side only. In that right side, it will take only the right side value and it will do this operation, that is self dot key, self is greater than less than, and after that it will be finding out the 74 has been present in the left hand side. So that is the condition. So after going to this, whole tree want to be implemented for the regressive function. Are you getting this? So as of now, we are going to look at, so this 4 line is only for this particular node we want to find out, and you are going to replace this. And where the 74 is in the tree? In the right hand side, right?
Yes, sir.
So you want to do a regressive technique for this 74 on the right hand side, and when you are passing the data as 74, then the regressive process will be working out and it will be producing the zero child process and it will be deleting this 74. That is the process.
Means it won't allow the duplicate, sir.
It won't allow the duplicate. We are changing the 74 here as of now. It means we are changing a 74 here as of now, but the main self dot key will be remains as whatever the value is 10. When you are returning this self only, the whole value will be changed because the condition has not been finished, right? Here you can see here this condition, when this process has been finished, only this condition will be changing. As of now, previously the self dot key will be remains as 10. You can change the code and you can execute and you will get an answer, different types of answers. I will execute this code now and I will send you the code also. You change the code and you try it out with different types of input, then you will find out the different types of answers also. Then you can easily understand. While you work outing the code, you can able to easily understand that. So for this, again, I want to print. Again, I want to call the root of delete operation. So before going to the delete operation, we will call this root dot pre-order operation and root dot delete DLET. So here I want to delete the node called 27. So I am deleting my root node, and how the process will be happen, you can see it. So if dot key is none. What is the mistake there?
In front side, one step forward. If before. Backward, one step.
This if this can. No?
Above, sir. If
So now, sorry, the root dot delete, and after that I will go with this pre-order. So I'm deleting the root node, and after that I am going with the pre-order technique. So first I am searching the node 30 and root node. So same, you can search the node as 27, and after that you can search the node root dot search of 27. So what will be the output now? first it will search the root of 27 and it will find out, yes, the key is found. Like that, it will be giving you a message. And after that, the delete process will be happen and delete the node as 27. And after that, it will finding out the pre-order process. Before that, you can go with this pre-order. Root dot pre-order. First, the pre-order will be executed and it will search 27 and it will delete 27 and it will find the pre-order without this 27 and it will search the element with the element deleted element, that is 27. So this is my pre-order technique. So this is my pre-order. So what we have done is my pre-order and the searching of 27. Yes, the searching as 27, the key is found. So after deleting, now the delete operation has been working out. Pre-order, search, delete. So one has been left out, search 27. So delete option, yes. So the delete option has been working out and it will finding out the 27 has been deleted. You can see here, right? The 27 has been deleted. And after that, the pre-order technique has been differ from this pre-order technique. So it will consider that root left and right and it will do an operation like this without 27. And after that, we can searching the same element called 27 that you will find out the result that node is not found. That is the technique. Clear? Have you understand the concept? What is the concept of pre-order, post-order, search, delete, and delete operation and all? Then this code, you just execute this code. What the example I have actually taken? You just execute this code. With you can change the values of this, and you can find out how it will be happen. So in this pre-order technique, we have want to draw a diagram for the diagram for the particular binary tree, and you want to find out the pre-order technique. And after deleting the 27 node, the diagram will be differ, right? The tree will be differ. And after the difference of the tree, we want to find out the pre-order technique that the node will be displayed like this. Clear? So the time is 11. So yes, those who are having doubts, you can stay back and ask the queries, or else you